Okay, good evening. How are all of you? ಹೇಗಿದ್ದೀರಿ ಎಲ್ಲರೂ?
Fine, sir. How are you, sir?
Fine, sir. How are you?
Fine, sir. How are
What?
you, sir?
Mega, are you there? Mega joined there.
Yes, sir.
What about others? How many have joined? 39. Okay, let us begin with the chapter electricity. I think few of you had attended the earlier class of electricity. Let it be. Once again, I will take the chapter. It's a very simple chapter. So, what are the contents? Can you all tell me what are the contents of this chapter electricity? First, I get ಎಲ್ಲರೂ ನೆನಪಿದಾವಿಲ್ಲ ಎಲ್ಲ ಏನ್ ಬರೆಯತ್ತೀನಿ ಬೋರ್ಡ್ ಮೇಲೆ. Can you all remember this?
Yes, sir.
Yes, sir.
Next. All of you, please take them down. Take this till the time I will reload that. I'll refill the marker. Please read them and write down. Did you write? Is it all right?
Yes, sir.
Now look here, let me explain to you. So these are the contents of the chapter, very simple chapter. What is electricity and what is electric charge? You know, their SI units and their formula will come here. Electric current, electric potential and potential difference. Circuit diagrams, Ohm's law. There is a very important law called as Ohm's law, where you will get about, we'll talk about electric resistance, factors affecting the resistance or which influences the resistance, electric resistivity, resistance in the types of different connection, how will be the resistor. First is series connection and second is parallel connection. Then heating effect of electric current. When we supply electricity, how does the object or how does the electrical appliance heat up? Last is the electric power. These are the important contents of the chapter. Shall we start now?
Yes, sir.
Boys?
Yes, sir.
Are you all present? So these are
Yes,
the
sir.
contents, very important chapter it is. Electricity, electric charge. Okay, let me wrap it. So don't worry, I have recorded, I've started the recording. Later on, you can see the recordings. So first of all, let us understand what is electricity. What is electricity? Can anybody tell me electricity? Can you see electricity? Have you seen electricity anywhere?
No, sir.
Why? Why you cannot see electricity? Can you feel electricity?
Yes, sir.
How can you feel the electricity? Yes, you can see the effects, different effects of electricity. If you touch, you will feel the sensation of electricity. So basically, what is electricity? It is a form of energy. Form of energy. So when we talk about electric, when we quote the term called electro means you will definitely learn about the charges. Few charges are responsible for this form of energy. When these charges start flowing, so there are electricity, there are different types. When the electricity flows, it is called as differently. When the electricity doesn't flow, it is called as differently. For example, electricity, when it flows, it is called as current electricity. When the electricity doesn't flow, it is called as static electricity. So these are the two different kinds we can say. Current electricity, the flowing current what we are getting at our house, in the vehicles, all these are called as current electricity. Static electricity, you must have played with the fiber chair. Have you any time played with the fiber chairs? Making somebody to
Yes, sir.
sit,
Yes. Yes,
hitting.
sir. Yes, sir.
Have you experienced the kind of shock or a spark?
Yes, yes, sir.
That is nothing but static electricity. You can also, you must have played with this, isn't it? You must have played with the scale, rubbing, and when you hold, it will absorb or it will attract few paper pieces. That is also static electricity because it will have electric charges, but it doesn't flow from one end to another end. Clear? So electricity is basically a form of energy. So what is responsible for this energy?
Charges.
What are
Charges.
these?
Yes. Charges.
Charges. So we have two main types of charges. One type of charges are called as positive charge. Second charge are called as
Negative.
negative charge. So what do we call
Charge.
these positive charges? What do you call these positive charges?
Protons.
Protons. And negative charges are called as.
Electrons. Neutrons. Electrons.
Electrons.
And we have something called as electrically neutral, which doesn't have any charge. You should not say that neutrally charged. It is not charged. It is called as electrically neutral. What that is called as?
Neutron.
Neutron.
Neutrons.
So these are the three main what are these? The three main fundamental
Fundamental particles.
So as these charges flow, we tell that the form of energy we obtain, that is electricity. So we obtain electricity by the flow of charges. Right? Now we have to measure this flow of charges. So basically you understood what is electricity now. Electricity is the form of energy. And what are responsible for this? The charges. So charges were first explained by a scientist called, what was the name of the scientist? Who was that? Coulomb. What is the name? Coulomb.
Coulomb.
So charges are denoted. They are denoted by Q. So wherever you hear or write Q now, Q means charges. Got it? So one more important, 1 coulomb of charge. When we say 1 coulomb of charge, can you tell me how many electrons are present in that? Yes? One coulomb of charge means 6 into 10 to the power 18 electrons are present. So what is the charge of 1 electron? Charge of 1 electron is equal to
1.6 into 10 to the power minus 19. 1.6 into 10 to the power minus 19.
minus 19 coulomb. So these are also important for your 1 mark question. You may get these questions. What is the meaning of this? 1 coulomb of charge will consist of 6 into 10 to the power 18 electrons, and 1 electron will have the charge of 1.6 into 10 to the power minus 19 coulomb. What is the meaning of this? And 6 into 10 to the power 18 means in front of 6, if you write 18 zeros, do you think the number is less or more? Kadime ideno just so many electrons ಇಷ್ಟೆಲ್ಲ electron ಕೂಡಿ 1 coulomb of charge ಆಗ್ತದೆ. So many electrons together. And what is charge of 1 electron? It is only 1.6 into 10 to the power minus 19. In the sense it is 1.6 divided by 19 zeros ಬರ್ತದೆ. Tell me the value is less or more?
Less.
Less.
19. Very, very, very less. So the charge of 1 electron is so less that all together so many electrons combine and form only 1 coulomb of charge. Clear? So basically charge means we think about electrons only, and protons also we should think about. So you can write this quickly, write down. We'll move further. Now let us start measuring the flow of charges. Shall I repeat? Now these charges, as you saw, first basically we learned these charges is denoted by Q. In the SI unit is C. C you should write in uppercase. If you want to write complete coulomb, you should write in lowercase. C or COULOMB. Coulomb, lowercase. The charge is denoted with Q. So when we start measuring this, measuring the charges, what we tell? Number of buses per hour. How many buses goes per hour here on the road? Isn't it? How many vehicles go per hour? Similarly here, how many charges go with respect to time? We are measuring with respect to time. That is charges with respect to time. Suppose see, I have a wire, a certain length of wire. I'll cut this cross section and I will check how many electrons flow from one end to another end per second. How many electrons from one end to another end they are flowing per second? That is called as electric current. So what is electric current? Number of charges per unit time. So this can be written as Q by T. Did you understand what is electric current? Electric current is the measurement of the number of charges per. Yes, come on. Can you hear me?
Time.
Time.
Per unit time and per second we call per second. So current is denoted by the alphabet called as I, and here also there is one scientist who is responsible, who told us this is the method of measuring the electric current, that is charges per. So what is the SI unit of Q? What is the SI unit of Q?
Coulomb.
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 Per time. What is the unit of time? How do we measure time? The basic unit
Ampere.
of time is
Second.
seconds. So this is Coulomb per second, which we name as capital A or
Ampere.
ampere. What is it? Ampere. So if you want to write the unit in shortcut, that is only A, you should write in uppercase. And if you want to write fully, you should write lowercase. What happens if you write uppercase A here? It becomes noun, name of the scientist. You have studied about noun, no? The name of the place, person, or a thing. Always it should be starting with the uppercase. So if you write uppercase, it becomes name of scientist. So you have to write the SI unit in lowercase or capital A. So this is called as electric current. Now comes the question. Reason why the charges are flowing. Why they are flowing? I'll give two examples to you. Just observe, here there is a water tank and there is a pipeline. Now, do you think if the water is full, if I open this area, do you think the water starts flowing from this end?
Yes,
Do you
sir.
think the water
Yes, sir.
flows?
Yes, sir.
Yes, sir.
Okay, I'll give you second scenario now. This is a water tank full of water. Here, I will take the pipe out. Okay. Now, do you think the water comes out here?
No, sir.
No, sir.
sir.
No, sir.
Really? There will be no water only? No water at all? ಎಷ್ಟೊತ್ತು ಬರ್ತಿತ್ತು ಬಾಳದ್ ಬರ್ತಿತ್ತು ಇಲ್ಲಿ ಹೆಂಗ್ ಬರ್ತಿತ್ತು ಇಲ್ಲಿಗಿಂತ ಕಡಿಮೆ ಫೋರ್ಸ್ ಅಲ್ಲಿ ಬರ್ತು
ಸರ್ ಅದಕ್ಕಿಂತ ಕಡಿಮೆ ಫೋರ್ಸ್ ಒಳಗೆ ಬರ್ತೈತಿ
ಅದಕ್ಕಿಂತ ಕಡಿಮೆ ಇರ್ತೈತೆ.
because of the gravity here. Gravity is pulling it. Here also there is gravity, but not compared to this because the distance here is more. Means the difference is more here. The difference is very less here. So this, when you take it on the higher position, you must have studied in your lower classes. The energy possessed due to change of position is called as. Quickly, tell me. Energy due to the change of position or change of shape, rubber band, bow and arrow. You must have studied this, no? What can you tell about this? Energy due to the change of position. Just imagine a scenario now. Now I'll tell you something. Just if you hold a small stone, just right above your head and drop it. Do you think it falls on your head? Will it fall on your head?
It will fall, sir. It will fall, sir.
If it will fall and you will sense little bit pain. One ಸ್ವಲ್ಪ ಆದ್ರೂ pain ಆಗುತ್ತೆ. The same stone, you take it to a higher place, at least 5 feet or 10 feet. Then you drop it. Same stone, same body, same head. Okay. Do you think the pain will be higher or lower?
ಹೈಯರ್
Higher.
ಪೆಟ್ಟು ಜಾಸ್ತಿ ಆಗುತ್ತಲ್ಲ, ಯಾಕೆ? ರೀಸನ್ ಬೇಕಲ್ಲ, ಯಾಕೆ ಜಾಸ್ತಿ ಇತ್ತು? ಅದೇ ಕಲ್ಲು 80 kg ಇದೆ. Force, why did that force increase? ಹೆಂಗ್ increase ಆಯ್ತು ಅದನ್ನ ಕೇಳ. I changed the position, isn't it? Which energy got increased?
potential energy.
Come on. Yes, very good. What is it? Come on, who is that?
Potential energy.
Potential. ಯಾರು ಇದು ಹೇಳಿದ್ದು? Ramu Patel. Very good. It is none other than potential energy. The energy due to motion is called as
Kinetic energy.
kinetic. So potential energy and kinetic energy. Similarly, here electricity will have electric potential. Electric potential in the sense, if I consider a small cell, A cell consider ಮಾಡ್ತೀನಿ. In the cell, you must have seen there will be different kinds of charges. Here it will be positive, and rest all the places it will be negative. So how many negative charges and how many positive charges are there? It will show its potential. Sir, ಒಂದ್ ಎರಡು ತಿಂಗಳಿಂದ ಸೆಲ್ ಯೂಸ್ ಮಾಡತ್ತೀವಿ ಅಂದ್ರೆ ಪೊಟೆನ್ಶಿಯಲ್ ಕಡಿಮೆ ಇರುತ್ತೆ, isn't it? Then if it is a brand new cell, it will have more potential. The more difference, the bulb glows more brightly. So this is called as electric potential and potential difference. So what is electric potential? Electric potential is nothing but the amount of work done to bring charges from infinity to a point. Lindo tattiruttala, that is called infinity. Illo ondu kade. Infinity to a point is called as electric potential. Potential difference is the amount of work done in bringing the charges from one point to another point. Everybody repeat. Amount of work done.
Amount of work done.
Work done in bringing the charges from one point to another point. ಹೇಳಿದ್ರಿ ಎಲ್ಲರೂ? ನನಗೇನು ಕೇಳಿಸ್ಲಿಲ್ಲ, ಮೈಕ್ ಆಫ್ ಮಾಡಿ ಹೇಳಿದ್ರಿ. So potential difference is the work done in bringing the charges. So work done, can you tell me the assignment of work done? Work done, ಕಲ್ತಿದ್ರಲ್ಲ? Work is said to be done when you apply force and the object displaces. Force into displacement is called as work done. Do you remember? Yes, somebody told that the assignment is Joule. ಅದನ್ನೂ ಒಬ್ಬ ಸೈಂಟಿಸ್ಟ್ ಹೇಳಿದ್ರು, ಅವನ ಹೆಸರೇ ಕೊಟ್ಟಿದ್ದಾರೆ ಜೌಲ್ ಅಂತ. ಕ್ಯಾಪಿಟಲ್ ಜೆ ಬರೀಬೇಕು, ಇಲ್ಲಾಂದ್ರೆ ಲೋವರ್ ಕೇಸ್ ಜೆ ಬರೋದು JOULE ಅಂತ. ಡಿವೈಡೆಡ್ ಬೈ ಕ್ಯೂ. ಕ್ಯೂ ದಸ ಯೂನಿಟ್ ಏನು? ಕ್ಯೂ 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 ಕ್ಯೂ
Coulomb.
Coulomb. So joule per coulomb. It can be also written as like this. If C mal bandra -1 will be in the exponent. Joule per coulomb is nothing but, what is it? Volts.
Volts.
So it is denoted as V. So not really. Electric current is denoted as I, and the SI unit is ampere. And the potential difference is denoted as V, and the SI unit is
Volts.
Tell me if there are any doubts. Now, how do we measure the charges? As we saw that electricity is flow of charges. When we start measuring the charges, it is nothing but charges per unit time, Q by T, which is ampere. It is our electric current. Okay, just there is water current. No, have you heard of water current? Flowing water is called water current. Flowing charges is called as electric current, and it is denoted by I. And what is the reason they are flowing? Because of the electric potential and potential difference. As there is difference here, gravity cannot work. Adar mass illa, electrons mass bala kadime, very 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 negligible mass it has. So gravity doesn't act. Gravity doesn't act at all. So we can tell that difference between these two potentials will give us the potential difference, that is joule per coulomb, which is volts. I hope you understood. Any doubts in this?
No, sir.
So we shall move further. I think you can write them later on. The classes are being recorded also. Now, as we studied about the charges, current, the potential difference, we should know how to draw them in the circuit. Circuit diagrams are very very important. What is circuit diagram? Who will tell me the answer? What is circuit diagram? What is circuit diagram? Yes, I will draw a small circuit diagram for you.
It is a graphical.
It is a graphical representation of an electric circuit. It shows the relative positive positions of all the elements and their connections to one another.
Very good. So a graphical, geometrical or a pictorial form of the circuit where we can understand where they are exactly connected to each other and how they are exactly connected to each other and from which direction the current is flowing. So as I told you, there are two types of electric current here. One is electron current, another is electric current. We always start the arrow mark from positive direction and we end at the negative direction. This end, the electric current, the electrons flowing from this end, the electrons are flowing from this end, that is electron current. The protons are flowing from this end, it is called as electric current. Got it? In the opposite direction of the flow of electrons. Electrons illinda allige ಹೊಂಟಿದ ಅಂದ್ರೆ protons allinda illige ಬರುತ್ತೆ. So there will be exchange of these two. So this is the electricity. All right. So here there are different, I think, circuit symbols. I'll show you. Circuit symbols. So circuit diagram is a pictorial form or a graphical form of the connection of the different electrical components. So what is this A andre no? What is this V and what is this like a speed breaker something looking like, and what is this part? What is this part? So we have to understand all this. So the first one, that is, what is it? It is called a cell. If these cells are connected in more number, it is called as battery. And this is called as resistor or resistance. Anyway, if you write this is called as emitter. What is emitter? Now comes the question, what is emitter? So emitter is here you should have written that there are different devices which are used to measure electric current and the potential difference. So ammeter is used to measure the electric current. Voltmeter is used to measure the potential difference. Which meter is used to measure the electric current? Ammeter. So this is V. V means it is voltmeter. Which is used to measure the potential difference across two ends. And this is positive, negative, positive, negative. Next, come on. What are the other? So if you draw the straight line, can you see this?
Wire.
So
Connecting wire.
Connecting wires. So if the wires have to be connected in joints, you can see here all the wires are connected in joint. Means all they are connected to each other. It is called as wire joint. Correct?
Yes, sir.
Next, if two wires should not be connected, it has to make a bridge. What it is called as?
Wire crossing without joining.
Wire crossing
Crossing without joining.
Wire crossing without joining. Okay, next. So here you can see this is called a switch or the key. If there is a dot here, it means it is closed switch. And if there is no key here, then it is called as open switch. This is just like the buttons we have our house. The buttons on off button. This is just like on. This is like off switches. Next, what are the others? This is
Electric
bulb.
circuit.
Bulb.
So bulb. So it will represent a bulb. If you are connecting any bulb, you can connect a bulb here also. See, if you connect here, it is a bulb connected. Next.
Variable resistance.
What is this? This is called variable resistance. Or it is also called as rheostat. It is also called as rheostat. It can be drawn it like this. The arrow mark also can be drawn. Rheostat. Connection. Next, anything is left? Any symbol is left?
Galvanometer.
Galvanometer. So don't worry, it will look like G. Galvanometer is also a meter which is used to measure the electric current, but galvanometer there is a difference. It can the direction of current. It goes from left to right or from right to left. Ammeter just measures whether there is current. If it is current, it shows the reading 1 ampere, 2 ampere, 3 ampere. But galvanometer shows the direction also, which direction the current is flowing. So this is a galvanometer. These are very important. You will be asked at least one or two from these all diagrams. They may ask you draw a simple circuit and explain what is a circuit. Different components are connected in this circuit. Those are explained here in this side. This is a cell, a battery, a resistor, ammeter, voltmeter, a wire. So especially we use different kinds of wire. We use the copper wire. We use a nichrome wire. Have you heard of nichrome wire? Nickel and chromium together they form a nichrome wire. The wire crossing each other. Here the wires are joined. Open switch, closed switch, bulb, electric bulb, variable resistor or rheostat, a galvanometer. Is there any doubt in any of the circuit diagram?
No, sir.
There are different kinds of numericals. We will solve all the numericals later on. Okay, there are different kinds of numericals. Very important numericals are present. We will solve them soon after this. Now, a relation between, there must be a relation between this V and I. Relationship. What is the relationship between V and I? What do you mean by relationship? What happens if I increase potential difference? What happens to the current? If I increase current, what happens to the potential difference? So these two are called as relationship. But they are together forming a relationship, and whether they are good friends or bad friends, we can know it very soon because one scientist made an experiment with these two. What did he do? He did very simple activity. He took a battery and he connected two different cells are connected in a different way. Okay. Next a key. There is an ammeter. Further, it is being connected. A resistor, especially a resistors, are connected here. You can measure it. So now you can see here, if suppose one cell has the potential difference of 1.5 volts, it is 1.5 volts, it is 1.5, it is also 1.5 volts. Alright, this is the ammeter which is connected and shows how much current is being passed. So you have to form a small table here to understand the relationship. Serial number, number of cells, then potential difference, current V by I, and at last you can write the conclusion of your experiment. Just observe what happens when I connect a different number of cells. Suppose I connect directly here. If I connect here, how many cells are connected here?
1.
Only one. So only one cell is connected, and the potential difference it gives us 1.5 volts. Suppose the current it gives us 1 ampere. Just for an example. So if I find V by I, it will be 1.5 divided by 1 will be 1.5. Let us see the second scene. Now how many cells are connected?
2.
Two cells are connected. When I connect two cells, 1.5 plus 1.5 it gives us
3 volts.
3.0.
3 volt. And the current it is showing as 2 ampere. Now again you can divide it. Is it 1.5 only?
Yes, sir.
Third. Now see how many I have connected?
3.
3.
3 cells. And it gives the potential difference of
4.5.
4.5, and it is ampere. So it gave us the current of 3 ampere, and divide it. What you will get?
1.5.
At lastly, I will connect 4 cells. What is the potential difference now?
5.
4.5 plus 4.5. Priya, 6 volts divided by 4 ampere gives 1.5. Can you see these are
1.5.
constant? These are constant. So if you draw the graph for this, so current I, potential difference V. If you draw the graph, it shows the constant rise. As I am constantly rising the current potential difference, the current is also rising constantly. Isn't it? If I am increasing current, if I am increasing the potential difference, what is happening to the current? It is increasing or decreasing?
Increasing.
Increasing.
Increasing. So we can tell that both are directly proportional to each other. So this is the diagram to know the relationship, which we call as
Ohm's law.
Ohm's law is the law which gives us the relationship between potential difference and electric current. Where anybody knows the statement of Ohm's law? Statement, please.
The current in a metallic conductor is directly proportional to the potential difference applied across its ends, provided the temperature and other physical conditions of the conductor are kept constant.
Are kept constant. So the current in the conductor is directly proportional to the potential difference applied. Or in short, you can say that the potential difference applied across the conductor is directly proportional to the current passing through the metallic conductor or any type of conductor. In short, you can just write that V is directly proportional to I. V is directly proportional to I. If I changes, V changes. If V changes, I changes. How it changes? If V increases, I increases. If I increases, V increases. Or else you can say if the potential difference reduces, the current also reduces. So both are directly proportional to each other. This is the Ohm's law. If you don't remember when during examination, during tension, sometimes it happens you don't remember the laws. You don't suddenly remember the laws. At least can you remember this? V is proportional to I. Can you remember?
Yes, sir.
This is what it says. Potential difference you can generate at the spot. The potential difference across the ends of a conductor is directly proportional to the current passing through the conductor. So now I want to remove this proportionality sign. So what I will do it, I will write equal sign. So if I write equal sign, I will have to multiply some proportionality constant then I. So it was proportional. Now I have to multiply some constant to this. So this is the formula. This is what we call as R. R is equal to V by I. So this new family member of our electricity is called as, what it is called as? Resistor. So we have got a new term which is called as resistor. So what is a resistor or resistance? So we can write it as resistance. Here also resistance. Resistor is a device. You can see here in the, you just saw in the circuit diagrams, isn't it? So let me rub this. This diagram is also very important, the circuit diagram. Many times it was asked in the examination. The circuit diagram to explain the Ohm's law. So now the formula of this resistance. Resistance is denoted by R. the formula goes as it is. V is volts divided by A is current, that is ampere. Volts per ampere. Hence, it is. Who gave this law? Who has given this law?
Ohms.
So the SI unit is taken with his name called as ohm. This is ohm. The SI unit of resistance is ohms. So what is this resistor? What is this resistance? What it does? Can I rub this? I hope you understood the Ohm's law. You have to understand what is resistance. What is resistance? Can you tell what is resistance? Suppose you are moving on the road.
Oppose the flow of charge.
It opposes the flow of charges. Suppose you are moving on a road. If it is simple plain roading, straight plain road, your vehicle will go very smoothly, no? ಆರಾಮಾಗಿ ಹೋಗುತ್ತೆ. ಅದೇ ಹಿಂಗ್ ಬಂತಂದ್ರೆ ಏನಂತಾರೆ ಏನಂತೀರಿ ರೋಡ್ ಮೇಲೆ ಇರ್ತಾವಲ್ಲ? Have you seen this on the road?
Humps.
Humps. ಮತ್ತೆ ಉಳಿದವರು voice
Speed breakers.
Is it clear enough?
Speed breaker.
ಸುಪ್ರಿಯಾ, ಐಶ್ವರ್ಯ, ಇದಿರಿ ಎಲ್ಲರೂ?
Yes, sir.
ದರ್ಶನ್, ವಿಶ್ವನಾಥ್. So these are called as speed breakers. ಏನಂತಾರೆ?
Speed breakers.
Not road breakers. Not road breakers, they are speed breakers. So here in our terminology, in our physics, we call it as resistance. Means which opposes the flow of charges. The charges want to go from one end to another end, but what it does, it opposes them. It stops them. So how much capacity of it to stop them? The resistance, we tell that it is in the higher region. And we have some factors on which the resistance depends on. Factors on which the resistance depends on. Okay, tell me what is the first factor. I'll give an example to you, just understand. Here there is a pipe. Here there is another pipe of the same cross-sectional diameter, same thickness. Okay, both are of same thickness. Here it is a pipe. I will allow some water to pass through here. I will allow some water to pass through here. Just tell me where will be the resistance more, in the short pipe or long pipe?
Long pipe.
Long pipe.
Long pipe resistance is more, means if length increases, the resistance also increases. So the first factor is the factor of length. If the length increases, resistance also increases. Okay, look at the second question. Both are of same length. Similarly, it happens with the electricity also. Don't worry, if you take a wire, just imagine, here is a switchboard. From switchboard, I will connect a bulb here. I will switch on the bulb, bulb will glow. Suppose if I plug in this switchboard and I will take it to at least half a kilometer or 1 kilometer away, do you think the bulb glows very brightly?
No, sir.
No, sir.
Definitely not, because as the length increase, resistance increase from this end to that end very easily. Because remember, current has to flow from one end and it has to reach back to the other end. There are two pins. One is live and another is neutral. So electrons have to flow from one end and they have to pass through all the circuit and come back to the neutral end. Then only the current, we say that complete circuit. Then only the bulb glows, or else the bulb will not glow. So let us check with the second one. Area of the cross section of the wire. Suppose you take very thin wire. You must have seen no thin. If you cut our copper wire, you will get strands of wire. So many multi-strands of wire. If you take a small thin of wire and connect to a bulb, do you think the bulb glows very brightly then?
No.
No. If you take a thick wire, Glows brightly now. You have seen your service wires, the wires which come to your house from the electric pole, service wire. ನೋಡಿದಿರಲ್ಲ ದಪ್ಪ ಇರ್ತಾವ ತೆಳ್ಳಗೆ ಇರ್ತಾವ ವೆರಿ ಥಿನ್ ದಪ್ಪ ಇರ್ತಾವಲ್ಲ ದಪ್ಪ ಯಾಕೆ ಇರ್ತಾವೆ ಕರೆಂಟ್ ಜಾಸ್ತಿ ಬರಲಿ ಅಂತ ಇಲ್ಲಾಂದ್ರೆ ಮನ್ಯಾಗ ಹಿಂಗ್ ಮಿಕ್ಸರ್ ಗ್ರೈಂಡರ್ ಡ್ರರ್ ಅಂತ ತಿರುಗಿಸ್ತೀರಿ ಅಲ್ಲಿ ಎಲ್ಲೋ ಡಮ್ ಅಂತ ಹಾರತ್ತೆ isn't it? So it happens. So we use thick wires, proper wires, because if the area of the cross section increases, that is the second factor. If area increases, resistance decreases. If you just think about the water pipeline, if you allow some water to pass through here and pass through here, ಎದುರೊಳಗಡೆ ನೀರು ಈಸಿಯಾಗಿ ಫ್ಲೋ ಆಗ್ತಿರುತ್ತೆ ಸಣ್ಣ ಪೈಪ್ ಇದ್ರೂ ದೊಡ್ಡ ಪೈಪ್ ಇದ್ರೆ
ದೊಡ್ಡ ಪೈಪ್ ಇದ್ರಿ
in bigger pipe it flows very easily. Similarly, wires also it flows very easily because the resistance reduces if the area increases. So when we talk about these two, length is directly proportional to resistance or resistance is directly proportional to the length. Here resistance is inversely proportional to area. It is called inversely proportional under 1 by. Look at this. Do we have same LHS?
Yes.
Yes,
So we write them as R is proportional to L by A.
Yes, sir.
Resistance is directly proportional to length. Resistance is inversely proportional to the area of cross section. So now we have to remove this proportionality sign. Then we will get R is equal to saw symbol one.
Rho.
What is this? Rho. Rho means electric resistivity. Rho andre electric resistivity. Clear? So now we have to write this electric resistivity denoted by rho. SI unit. What is the SI unit of rho? Let us see. A ಈ ಕಡೆ ಬರುತ್ತೆ length ಕಡೆ ಹೋಗುತ್ತೆ. So rho is equal to R into A divided by L. The formula to calculate rho is RA by L. What is the SI unit of R? R andre ಏನು? What is R?
resistance.
What is the SI unit? What is the SI unit of area? Area of rectangle ಅಂತಲ್ಲ ಏನು SI unit ಕೊಡ್ತೀವಿ?
Meter.
meters ಅಂದ್ರೆ ಲೆಂತ್ ಆಯ್ತು rectangle meter square divided by length ಅಂದ್ರೆ meter 1 meter cancel. What remains here? Ohm meters. So ohm meters is the SI unit of electric resistivity. So different objects will have their own resistivity rates. For example, iron, aluminium, copper, sand, different will have their own resistivity. As the resistivity increases, they become insulators. As the resistivity decreases, they become good conductors. Isn't it? Can you tell me the range of a good conductors? Good conductors. Quickly. Rachna. Can you hear me? Is there any network problem?
No, sir.
Tell me the value of the range of the electrical resistivity range of good conductors. Quickly. I had given you this, you had written this. Where is the book? God knows.
10 to the power of minus 8.
10 to the power of minus 8 and
10 to the power of minus 8 to 10 to the power
Minus 6.
minus 6.
minus 6 ohm meters. Then they are called as good conductors. Insulators,
10 to the power of 12.
Power of minus 12.
not minus 12, plus 12, 10 to the power 12 to
10
to the
to the
power
7.
yes 7
17.
ohm meters. So you know what are good conductors which allow the electricity to flow. For example, metals. There are so many metals: iron, copper, aluminum, silicon, which we call as semiconductor actually. Germanium, that is also a semiconductor. Insulator, rubber, glass, wood, all these are insulators which will not allow the electricity to flow. Why they are called as insulator? Because their resistance is high. When the resistance is high, the charges cannot flow from one end to another end. If you want to change any circuit or if you want to switch the fuses and all, what kind of chair do you suggest people? Metallic chair or wooden chair?
Wooden chair.
Because
Wooden chair.
wood is an insulator. It will not allow the electricity to pass. Whereas iron chair andre, iron chair ಮೇಲೆ change ಮಾಡಕ್ಕೆ ಹೋದ್ರೆ straight away ಹೊಗೆ ಹಾಕಿಸ್ಕೊಂಡ್ಬಿಡ್ತಾರಲ್ಲ ಅದಕ್ಕೆ. So you should be careful. And what type of slippers they ask you to wear? Metallic slipper, rubber slippers.
Rubber.
Rubber, because the rubber is an insulator. Similarly, your all switches, all switch nodri ಬೇಕಾರೆ, they are made up of plastics. Plastic is an insulator. Current ಅದ್ರ ಒಳಗಿದೆ, ಆದ್ರೂ ಇಲ್ಲಿ ಕೈ ಇಟ್ಟರೆ ಹತ್ತಲ್ಲ ನಮಗೆ. ಬಟನ್ ಮುಟ್ಟಿದ್ರೆ ಕರೆಂಟ್ ಹತ್ತಲ್ಲ. Okay, it will not pass through that insulator because its resistivity is high. Clear? So we had written two of the factors. First factor is length factor. Length increases, resistance increases. Second is area factor. Area increases, resistance decreases. Next, can you tell me other? Type of material, it becomes a good conductor and insulator. Next, temperature of the conductor. If temperature increases, resistance also increases. So the cold environment, cold then the resistance will be low. Temperature ಜಾಸ್ತಿ ಆಯ್ತು, resistance ಜಾಸ್ತಿ ಆಗುತ್ತೆ. ಅದು ಹೆಂಗೆ ಅಂತ ಕಲಿಬೇಕಂದ್ರೆ first you have to write down these. At least you can take a screenshot of these. I'll explain you how the temperature plays a role in resistance. Can I repeat? So these are two important parts you studied: charge, current, potential difference, resistance, electric, resistivity. Very important parts. They are denotion and their assignments and the meters to measure. This meter resistance ಯಾವ meter ಇರಲ್ಲ, already it is a device only, variable resistance. I'll tell about a situation now. Just imagine a small situation, very small situation. What is heat actually? Heat ಅಂದ್ರೆ ಏನು? Heat is also a form of energy. In heat, it is a cause. Temperature is the effect. Heat ಯಾವಾಗ ಜಾಸ್ತಿ ಆಗ್ತಿತ್ತಲ್ಲ, temperature ಯಾವಾಗ rise ಆಗುತ್ತೆ. So heat is called as a cause, temperature is the effect. So heat is also a form of energy. Heat one form of energy there. How this heat is, how do we measure the heat? Heat is nothing but the total kinetic energy. Suppose it has some heat, idar mele ಸ್ವಲ್ಪ heat ಇರ್ತೈತಿ. It will be having some temperature, means it has some heat. My body will have some heat because I will have some temperature. So the particles on this will be in motion. Idar ಒಳಗೆ particles ಏನು ಇರ್ತವಲ್ಲ, the atoms, the molecules, they will be in motion. Motion ಕಲ್ತಿರಲ್ಲ, linear motion, to and fro motion, vibratory motion, ಇವೆಲ್ಲ different types of motion. ಇವು ಒಳಗೆ vibrate ಆಗ್ತಿರ್ತವೆ, ringing, oscillate ಆಗ್ತಿರ್ತವೆ. Everywhere they will have motion. ಅದು ಎಷ್ಟು ಸ್ಪೀಡ್ನಾಗ ಆಗ್ತಾವಲ್ಲ ಅಷ್ಟು ಟೆಂಪರೇಚರ್ ಜಾಸ್ತಿ ಆಗುತ್ತೆ. Remember. Okay, I'll tell you a small example. Suppose you are standing in a room. One room ಇದೆ. Okay, there are two doors here. And there are so many particles walking around inside. You particles walking around. ಎಲ್ಲಿ ಬೇಕಲ್ಲಿ ಡೈರೆಕ್ಷನ್ ದಾಗ ಅಡ್ಡಾಡತ್ತೆ. ಒಂದಷ್ಟು ಮಂದಿ ಅಡ್ಡಾಡ ಒಳಗಡೆ ಇಷ್ಟು ಜನ ಅಡ್ಡಾಡತ್ತೆ. You are from the gate A to gate B. You have to pass from A to B. ಹೇಳ್ರಿ ಈಗ. If these are moving at very fast speed, ಈ ಒಳಗಡೆ ಏನ್ ಬಾಡೀಸ್ ಇದಾವೆ ಬಹಳ ಸ್ಪೀಡ್ ಆಗಿ ಅಡ್ಡಾಡಕತ್ರೆ ನಿಮಗೆ ಇಲ್ಲಿಂದ ಇಲ್ಲಿಗೆ ದಾಟಕ್ಕೆ ಈಸಿ ಆಗುತ್ತೋ ಡಿಫಿಕಲ್ಟ್ ಆಗುತ್ತೆ?
Difficult.
When they are moving with very less speed, singing, walking ಮಾಡಿದರೆ slowly, do you think you can pass from A to B easily or difficultly?
Easily.
Easily.
This is what I want to tell. This is nothing but a charge. It wants to go from the point A to point B. A ದಿಂದ B ಚಾರ್ಜ್ ಹೋಗ್ಬೇಕೀಗ. It is a conductor. It is a conductor. ಇದೆ ವೈರ್ ಅಂತ ಕೊಡ್ರಿ ಕಂಡಕ್ಟರ್. ಇಲ್ಲಿಂದ ಇಲ್ಲಿಗೆ ಹೋಗ್ಬೇಕು. ಇದ್ರ ಒಳಗಡೆ ಪಾರ್ಟಿಕಲ್ಸ್ ಮೂವ್ಮೆಂಟ್ ಅಲ್ಲಿ ಇದೆ. ನೀವು ಹೀಟ್ ಹೆಂಗ್ ಮಾಡ್ತೀರಿ, ಟೆಂಪರೇಚರ್ ಹೆಂಗ್ ರೈಸ್ ಆಗುತ್ತೆ, ಇದ್ರ ಮೂವ್ಮೆಂಟ್ ಫಾಸ್ಟ್ ಆಗುತ್ತೆ. ಸೊ ಡೋಂಟ್ ಯು ಥಿಂಕ್ ದೇ ವಿಲ್ ಬ್ಲಾಕ್ ದ ವೇ ಆಫ್ ಚಾರ್ಜಸ್? ಇಲ್ಲಿಂದ ಚಾರ್ಜ್ ಹೋಗ್ಬೇಕಾದ್ರೆ ಬ್ಲಾಕ್ ಮಾಡ್ತಾವೋ ಇಲ್ಲ? If temperature rises,
Yes, sir.
if temperature reduced, the charge can flow easily. So we tell that if temperature increases, resistance also increases. I think it is clear to you. Factors affecting the resistance. So there are different kinds of numericals given in this. In the next coming classes, we can solve those. Tell me, what is the next concept after the factors? Electrical resistivity. Electrical resistivity ಆದ್ಮೇಲೆ just now I had given some.
Connections.
So different types of connections we can make with the resistor. So resistance in a different variety of connections. So let me rub this. There are basically two types of connection. Gottidella? There are basically two types of connection. If the batteries are connected like this, see, positive, negative, positive, negative, positive, negative. Positive end is connected to negative end. Negative is the end is connected to positive end. Such type of connection is called as
Series.
Whereas look here, how these are connected to each other. So positive, all the positive ends are connected to each other. All the negative ends are connected to each other. This type of connection is called as
Parallel.
connection. Now instead of the batteries, we will connect the resistors. Okay. So let us see how will be and what will be the resistance when we connect them in series and in parallel. I'll give the examples. So resistors in series, resistance when they are connected parallel. So first just observe carefully. Resistor 1, resistor 2, resistor 3. Resistor 1, resistor 2, resistor 3. So let me complete the circuit. Can connect an ammeter. So this is how we connect the resistors in parallel. This is how we connect them in. How I have connected. For each you can connect voltmeter. So how many resistors are connected here? R1, R2, R3, R1, R1. I think you understood the difference of the connection. Here they are connected end to end, positive, negative, positive, negative, positive, negative, and this is the direction of electricity flowing positive to negative. Similarly here positive, negative, positive, negative, positive, and negative. So this is positive, negative, close back. Look carefully, understand the diagrams. Here to find the equivalent resistance, which we call as, what we call these as?
Equivalent resistance.
Equivalent
Resistance. What is the equivalent resistor? ನೀವು ಮೂರು ತೆಗೆದು ಒಂದೇ ರೆಸಿಸ್ಟರ್ ಹಾಕೋದಾದ್ರೆ ಎಷ್ಟು ಹಾಕಬೇಕು? ಒಂದು ಕ್ವಶನ್ ಅದು. It is called equivalent resistance. That is given by Rs is equal to R1 plus R2 plus R3. Similarly, coming to the other side, if you want to find the equivalent resistance, here you will get 1 by Rp. Rs ಅಂದ್ರೆ ಏನು? Equivalent resistors connected in series. ಹೇಳಿ?
Equivalent resistors connected in series.
Resistance connected.
Rp ಅಂದ್ರೆ? Rp means?
Equivalent.
Equivalent
equivalent resistance is connected by parallel.
Connected parallel. So 1 by R1 plus 1 by R2 plus 1 by R3. It depends. It depends on how many resistors you have connected. I have connected 3, so I wrote only R1 plus R2 plus R3. If I have 5, I'll write till 5. Similarly here. So you will solve madi. There are problems. Let's discuss the problems in the next class. Okay, all the different kinds of problems. Till here, please understand these. These are very important, especially 3 to 4 mark questions you can expect from these. 3 to 4, especially the CBSE students, understand these are very important. They will give the situation here and they will give different kinds of problems to calculate the current, to calculate the potential difference, or to calculate how much amount of potential difference is applied. So these are very important. So in the next class, that is tomorrow at 4 p.m, I'll be discussing the same topic, different numericals. If you really want to get 4 marks at least in this chapter, so what all you should know? You should know these numericals, SI units, formulae, definitions, especially the law. Which law it is?
Ohm's law.
Ohm's law. So you should remember the Ohm's law. You should know what is current, SI unit, denotions, and even the circuit symbols. ಗೊತ್ತಾಯ್ತಲ್ಲ ಇವತ್ತಿನ ಕ್ಲಾಸ್ ಏನೇನಿದೆ ಇನ್ನೊಂದು ಕೂತು ಈ ವಿಡಿಯೋ ನೋಡ್ರಿ, ಜಸ್ಟ್ ಅಬ್ಸರ್ವ್ ಕೇರ್ಫುಲಿ, ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಇಟ್.